We got this tile pattern right here. It's a little bit more complex because we split each parallelogram in half along the diagonal here, and so we have a bunch of triangles here. Let's see if we can find any relationships between these. All right, to find congruent angles in this, we're going to take a triangle here, and we're going to just highlight one corner. We are going to slide it around to see if there are any other angles that are congruent. So we know that this angle matches here, and it matches here, 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 here. All right, what if we take our triangle and we flip it upside down here? Are there any other angles that we can find that are congruent to that same angle? It looks like here, 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 which makes sense, right? Because these are alternate interior angles, so we know that they would be congruent. If it's easier to see with the tracing paper, that works. We'll fill those in. All right, so this is what it looks like. We could have also used vertical angles here to show that these angles are congruent as well if we didn't want to use the tracing paper. Let's try coloring other corners of this triangle. What if we go for this corner right here? Let's color all those in blue. All right, so now this is what our pattern looks like when we have 2 of our 3 triangle angles filled in. We're going to color in the third one and see if we can find any patterns as a whole. All right, this is what our pattern looks like filled in with our 1 tick mark, 2 tick mark, and 3 tick mark congruent angles here. We're going to zoom in on a certain section here to see if we can find a relationship between the 3 angles of a triangle. Let's look at this specific section right here. If we see here, this is a supplementary angle. And so we know, since we see the 1 tick mark, 2 tick marks, and 3 tick marks, that I can rearrange this triangle and it will be supplementary. So our relationship is that all triangles add up to 180 degrees. All right, so this is called the Triangle Angle Sum Theorem. We know that any 3 angles in a triangle will add up to 180 degrees. All right, here we have zoomed in on our tile pattern here. We got our 1, 2, and 3 tick marked angle here. And we know, because of alternate interior angles, that A is congruent with D and E is congruent with C. All right, so we can write this as angle A is congruent to angle D and angle E is congruent to angle C because they are alternate interior angles. Another relationship we notice is that D, B, and E are supplementary. So these all add up to 180 degrees. All right, so we know D, B, and E add up to 180 degrees because they form a straight line all together. We can swap out, since A is congruent with D, we can swap out D with A, and B is still itself. We can swap out E with C, since we know they are congruent. And so we've just proven that angles A, B, and C, or any angles of a triangle, add up to 180 degrees. Let's show you this cool animation as well that can verify that for us. Using this applet from GeoGebra, we can see another visualization of the Triangle Angle Sum Theorem. If I move this slider, I see that these angles match up with those angles up there. And so these are alternate interior angles, and because the blue, pink, and green form 180 degrees, and they match up with those angles down the bottom, we know that a triangle's angles, the blue, pink, and green, have to add up to 180 degrees. All right, we have talked about the angles of any triangle add up to 180 degrees. We're going to see if we can find out a property about the sides of a triangle. So we got triangle ABC here. BC is 8 centimeters, AB is 6 centimeters, and what are the possibilities for this third side?
Here we have 3 different side lengths for CA, and we want to see if we can create a triangle. We're using inches, so it's a little bit easier for you to see. So we have 6 inches here, which is representing the 6 centimeters, 8 inches, which is representing the 8 centimeters, and we're going to see, can any of these 3 different side lengths create a triangle? So if we start with this top one, 27 inches, we have our 8 inches and our 6 inches, and we see if we can somehow create a triangle. But pretty quickly we can see these sides are not long enough. There's no way we can connect these 2 sides and create a triangle. All right, let's try 14 inches now. If we have our 8 inches and our 6 inch side, and we want to see if we can create a triangle, as we bring these sides together, it looks like they're almost going to connect, but then they just lay flat on this line. But that makes sense because this third side is 14 inches, and then we have 8 inches and 6 inches. 8 plus 6 is 14. So it makes sense that it would make a flat line. Now let's come over here to 5 inches. If we move these sides, you can see they do create a triangle. What we can conclude from this is 2 sides of a triangle. If you add these 2 sides together, if you add 8 and 6 together and it is less than the third side, there is no way that we can create a triangle, right? 8 plus 6 is 14, and that is way less than 27. So there's no way for us to create a triangle here. And then if we add together 8 plus 6 here, we get 14, which is a straight line, which matches the third side. The two sides added together have to be bigger than the third side. They cannot be equal to the third side. And that's why this one over here does allow us to create a triangle. So as long as our third side is less than our two sides added together, we can make a triangle. And that is called the Triangle Inequality Theorem. So the sum of two side lengths of our triangle have to be greater than the third side. So 8 plus 6 is not greater than 27. 8 plus 6 is not greater than 14. It's equal to 14, which creates that straight line. But 8 plus 6 is greater than 5.
All right, let's look at some examples here where we want to apply the triangle inequality theorem. So given these three sets of sides, will this make a valid triangle? Let's use our triangle inequality theorem to help us. We know that the sum of any two sides of a triangle has to be larger than the third side. So if I add 5 and 3, that's going to give me 8. 8 has to be bigger than the third side. 8 is not bigger than 10, so I know that this is not going to work. This triangle would maybe look like if I had a 10, then I'd have like a 5 here and a 3 here, and they wouldn't be able to meet up because we'd have like a little gap there. All right, let's check out this next example here. We got 4, 12, and 9. Let's try 4 and 12. 4 plus 12, is that bigger than 9? And yes, 4 plus 12 is 16, so 16 is bigger than 9, so that would work. Doing it for just one side isn't enough to prove that this is a valid triangle. There could be a different pair of sides that might not be bigger than the third side, so we have to check the other combinations as well. So we got 12 and 9. 12 plus 9, is that bigger than the third side? 4. 21 is bigger than 4. All right, and then our last combination we need to try is 4 and 9. 4 plus 9, is that bigger than 12? 9 plus 4 is 13, and 13 is bigger than 12. So we know that this is going to create a valid triangle because any two of the sides that I added up was bigger than the third side.
Let's take a look at number 3 here. We have side lengths 5, 2, and 4. So let's try adding together the first two. If we do 5 plus 2, is that bigger than 4? Well, yes, because 5 plus 2 is 7, which is bigger than 4, so that works. Okay, let's try 5 and 4. 5 plus 4, is that bigger than 2? 9, which is greater than 2. Okay, let's check the last set of sides. We want to check 2 and 4 and see if that's bigger than 5. Come up here. So 2 plus 4, is that bigger than 5? 2 plus 4 is 6, which is greater than 5. So this one would be a valid triangle. All right, let's check out number 4. We have 3, 5, and 8. So let's just add these two together here. We got 3 plus 5, and is that bigger than 8? Well, 3 plus 5 is equal to 8. 8 is not bigger than 8. So that won't work. So we know that this will not make a valid triangle. If we were to try to draw this, we would maybe have side 3, side 5. And if we tried to connect these, they would just lay flat because 3 plus 5 is equal to 8. And it has to be bigger than the third side.